What is a container? Why do people always use words like container and image? What the heck is it? Technical definitions say something like a Docker container image is a lightweight, standalone, executable package of software. That's booty. Let's take a step back. A container is not really magic. It's a file. More specifically, it's an image file. No, not like GIFs. It's more like a snapshot of a hard drive. Long ago, people realized that they could back up their computers by storing a version of their files. They could then load it back on their computer at any time. This was called a disk image. Before disk images, computer administrators would set up computers at the same time, kind of like you do laundry. They would start at one computer, plop in a disk with the operating system, then go down the line and keep installing on the next computer. Sometime later, it would finish the install, and they'd go through and set up the next software. They would set up settings and install programs one machine at a time. Eventually, they'd get to the point where they had everything needed for a computer to have a user login. After disk images, all they needed to do was load the image. Then they would set up a user and assign a permissions group. Just done that quick. A container is a smaller version of a disk image. Rather than packaging an entire computer system, we're just packaging up a program. You don't need to copy 30 gigabytes of an operating system for every program we load. We can install an operating system once, and then load everything into a container, and then we can just use the operating system you have installed. This allows us to cleanly install and remove a program, much like we do on our phones. The app we install has everything it needs to run. Now the question is, what makes up an image? There are really two parts. You declare an operating system to base your image off of, and you add your program files. You can layer containers, so if your container uses one base, then you can add another base below it. An example would be having the base be the operating system, then another container inherits from that base to add a Python layer, and maybe the next container inherits off that Python container to add a Java layer, and then you can add your steps to add whatever you need. Going back to Docker's definition, it might make a little more sense now. A container is a standard format that contains your app and everything it needs to run, so that it's easy to run or deploy. Docker is just one standard, but in some ways, they invented the easiest and most successful user interface. They created unified tools and instructions to create containers. Docker was really a user-friendly format, which is why most of the conventions are still used in other newer tools. You learn how to use Docker, you're really learning to use the language of many cloud tools. Docker had a number of products, but the main driver of its success were the Docker CLI and the Docker file. The Docker file described the steps to build your image. It consisted of command line steps. Then the Docker CLI would read those steps and build your image for you. Once built, it would submit that image to a repository. An image repository is just an easy way to get or save container images and have access to them. Think of it like an app store. To differentiate containers in the store, they are given tags. These are like versions, but they can be a mix of letters and numbers. So tags can describe versions, features, or compatibility. In reality, a container is just a running instance of an image. Docker is just one format. It's the basic building block of cloud infrastructure. In the next video, we're going to take a leap and look at pods and deploying containers.